Okay, so we're gonna do question 6. Whew, it's getting exhausting. We're gonna go through and we're gonna figure out how to do this one. Now this one requires our calculator, so let me bring that up. You're going to basically do what's called the line of best fit on it, because you have a basically a table, and you need to figure out which one of these questions best. And it usually will tell you best models, best fits, whatever. All right, so I'm going to put in the go into stat menu. Okay, click edit. You're going to put in your x values. In fact, they even tell you which one's x and which one's y. L1 is always your x's and L2 is always your y's, unless you change that. Okay, let me put those in for us. 55, 125. Let's see, and then 2100. I have to figure out a way of speeding up the video so you're not sitting here watching me do this. Unless, of course, you're doing this along with me. 40, 3, 2, 5. Alright, so I got the data in. You hit stat again, and then you go over to calculate. And then since we're looking, now if you look at the x is in the exponent. So this is an exponential, this is an exponential, this is a line, and this is a line. You really need to know your stuff, because if you notice, everything here is described by what type of function it is. And if you didn't know that that was an exponential, then you're pretty much hosed. So you have to know your stuff pretty well. All right, so we got exponential at best fit. I hit enter. And if you look and see that it says put 997 in for A, put 1.03 in for B, raised to the X, and that actually describes B. So I'm done. I mean, I didn't really have to do much work at all. So that's how you do that one. Oh, somehow I have this stuff in here. Alright, so I'm going to do the z-table stuff. So, I mean the normal distribution stuff. So you got to make yourself a bell-shaped curve. That's pretty ugly. But anyway, you get the idea. The highest hump here is called the mean. Okay, why am I not using my pen? I'm not quite sure. I was just using my mouse for a second there. Alright, so this is my mean, and it says that's 108. And my standard deviations are 11. So what I'm going to do is kind of add 11, so I kind of figure out where my number is I'm looking for. If you notice, I'm looking for what number? I'm looking for 125. So 125 is like kind of in here somewhere. Alright, so I'm interested in all of this, and the reason is because I'm looking for above. So I'm interested in this. Now what you do is you use your z-table. So what we're going to do first of all is use our equations, and if you bring up your formula sheet, which I don't have in front of me, you have a formula that looks like this. Okay, this means the value that you have minus the standard, the mean. Okay, this is a mu. Or sorry, yeah, it's a mu, and that means the mean. Wow, a lot of that. And this is a standard deviation. On the formula sheet, I believe they tell you all that, so you just have to look at the key right above it and it tells you all that. So I'm doing 125 minus the mean, which is 108, all divided by 11. So it looks like I want 17 divided by 11. Whoops, 11. I don't know why I just did that. Kind of glitched there. Divided by 11. Alright, so I'm going to put that in my handy dandy calculator. And let's see if I can bring that up a second. I mean, you can do it on a regular calculator, but since I have this thing handy, okay, I want to just do 17 divided by 11, and that's 1.545, so I'm looking for 1.55. The reason why you want to go 2 decimal places is because when you bring up your z-tables, which are where? Whoops. Wow, that was interesting. You gotta go z-table. Okay, here's my z-tables. These are basically you can get these right on your test. You just have to click at the top where the tools are, and then which are, let me show you. They're up here where the forms are. If you click that, you get this Z table here. So we're interested in 1.55. Now, if you notice, this has all the negatives. Okay, the reason why these are negatives is because you haven't made it quite to the mean yet. So anything to the left of the mean is going to come out to be a negative, because negative standard deviations are less than the mean and positive standard deviations are past the mean. So if you go to page 2, this is when it makes it past the mean, and if you notice, that's where my value is. My 125 is past the mean, so I'm going to be looking at this paper. Now, if you notice, the white here matches the white I need. However, the Z table only produces the gray part. So, in case you didn't know this, the area underneath the curve is 1. So, equal to 1. So, what I'm going to do is I'm going to find my Z-score in a second, and then I'm going to subtract from 1, and that's going to give me my probability. So, I'm going to look up 1.55. So, I'm going to look up 1.5, which is right here, and then I'm going to go to the 5 right there, and that looks like it gives me 1.9394. Yes, 0.9394 looks like. 0.9394. Alright, put that away. Okay, 0.939. Come on. What's happening? Oh, my tablet's having fun. Alright, 0.9394. Now that would have been if I had looked for all of that, but I want this piece. So I want to do 1 minus 0.9394, which is like 0.0606 or something like that. Alright, so this is a very small probability. Okay, very tiny, because this is the tail end of this. It's a tiny little bit, and look, it doesn't want what you call it. It wants the how many out of the data, out of the values. So you're going to take this number and you're going to multiply it by 968, and when you do that, you will get 59. And that's how you do that. So if you move the decimal point, it's like 6%. It's really a small amount of the 968. The rest of these are way, even if you were to guess, I would hope you would knock out A and B, because see this tiny little bit? It's only a little bit. So it wouldn't make any sense to have, this is saying I have 910 values in that little area, which doesn't make any sense. So even 789, I wouldn't even guess that. Now I'd be down to these two, but still, since this is a small little sliver, I would still guess 59 if I had to. So let me just go on to the next one. Okay, this one is going to be hard to do because I can't really slide like you can on the test. But this is one of those divide and one of those click and drag ones. So I'll just have to kind of put arrows there because that's all I can do. Alright, to do this, all you're doing is look at the first line and tell me what is the difference between this line and this line. What'd you do? And then you just justify it by writing in the steps. So from here, from step 1 to step 2, it looks like I did the distributive property. So this guy is going in here. Okay, now from this one to this one, it looks like these two guys have swapped places. So that's the commutative property that goes in there. And then I've got, looks like I just threw some parentheses down on there. Looks like that's the only difference between these two. So anytime you play around with the parentheses without distributing, that's the associative property. So that's going in here, and then you're not using the others. So those would be the things you would click and drag over into the spots. And that's it for that one. Alright, next. Alright, ooh, sequences in series. Alright, this looks a little bit tricky because most people have not seen these most of the time in their life. They just saw it in Algebra 2, probably got it at the end of the year, your teacher probably rushed right through it, and bam, here it is, you got to do it. Okay, so what this is saying, if I explain this well enough, I hope, is this a to the n means any term I'm trying to find, and this a to the minus 1 represents the term that's right before it. Term before. That's all that means. And so in order for me to use this, I have to keep going to the number before it. So what they do is they always give you whenever they want to do something like this, they give you the first term. So the first number in the sequence is an 8. Okay, it says here to find the an. In this case, I'll be looking for a2 because that's the second term, and then I'll be looking for a3. That's the third term. This is a1. Alright, if I'm looking for a 2, this is a 2. If that's a 2, then this is a 1. So right here, all it's saying is 2 times a1. Well, 2 times a1, 2 times a1, which is 8, plus 5. I get 21. That's the second term. Okay, the third term says, hey, to find the third term, take 2 times the second term plus 5. So I'll do 2 times 21 plus 5. That's 47. So 47 is what you write in here, and that's all you're doing. Okay, so this, again, these little notations, all this means is whatever term you're trying to find, the little a sub n minus 1 means the term before it. That's all that means, and don't let that kind of throw you off, but that's all that means, is this shorthand for, yo, go get the term, the number you just wrote previously. Okay, this one is pretty tricky. You have to really know your functions pretty well, otherwise you're putting these all in the calculator looking at them. So it says here, identify each function with the same range. So the y values have to be pretty much, so how would you describe this? Well, if you go look at it, you're going to get, well actually let's go look at it, hold on a second. Alright, so in the calculator, we're going to put in the absolute value. Now, I never remember where the absolute value is, so I always tell my kids hit second in catalog, and it's usually the first thing on the menu. So I don't even remember where it ever is. I think it's somewhere in the math key, but I never remember. Alright, so look at that. Now, hopefully, you already know your functions pretty well, and you already know what happened. If you know what the parent graph does, then this is fairly easy. You already know that the graph is hopefully is moved down to 4. So really, here's the way I kind of tell my kids how to do this. See, there's really arrow points on here. So what you're really doing is a y. You're going to start here, and you're going to say whatever this number is. That number is -4, and since the arrows are pointing up, that means y has to be greater than or equal to -4. So that's what kind of range I'm looking for. Now, if you put this one in the calculator, hold on, let me bring my calculator back up. I don't know where it went. Alright, if I put in this in the calculator, if you're not sure, definitely put them in. Let me put in x squared because this thing is not in vertex form, so you might want to take a look at it. You got plenty of time. Take a look at it, see what you think. Okay, that looks like that goes down to -4. Let's double check. Let's go to the table and check it out. Nope. 0, -3 looks like. Yep, there's -4 right there. And then let's see if it goes back up again. And then it's going back up again. So it's going down as low as -4 as well. So that is an answer. So this guy is an answer as well. X cubed minus 4. If you know what the x cubed graph does, you're not going to pick this, because an x cubed graph goes like this. That is definitely not stopping y at -4, so that's out. If you know your exponentials, okay, your exponentials look something like starting off really, really low and kind of taking a huge increase. The analogy I gave my students was the millionaire scenario, where I give you a penny one day, 2 pennies the next day, and 4 pennies the next day, and after 30 days you end up with $5.5 million. So it's crazy, but all that's going to do is move it down to 1, 2, 3, 4, 5 down here, and so your graph kind of goes like that. It's a rough estimate, but looks like that. And then you've got an asymptote line sitting down here. Well, the fact that you got even below -4 says this is out. Okay, the square root of x minus 4. Okay, again, if you know your parent graphs, and this normally would go like this. Well, this graph's moving it down to 1, 2, 3, -4, so it's doing the same thing. So y is as low as -4, so that is an answer. Okay, so check on that one. And then this one, if you know, again, if you know your parent graphs, and again, I haven't put any of these in the calculator, just there's my x squared graph. X minus 4 moves the graph to the right. 1, 2, 3, 4. So your y is still 0. So it's definitely not falling into this at all either. So this is out. So your correct answers are the first one and was that the fourth one. Those you have to get both of them. If you miss one of them, you miss the entire question. There's no partial credit. So let's go on to the next one. Okay, indicate the intervals where the graph is only increasing throughout the interval. Okay, intervals, just to describe intervals, intervals are the x's that follow what they want. So, for instance, if I'm looking at the graph, let me put this graph up. Hold on a second. Okay, so I have my calculator set up. I also have the equation put in. I'm going to take a look at it and see what's going on. So I'm going to hit graph. Okay, now even though I can't see all of it, I know what a cubic does. It starts below and kind of it swings up, comes back down, and goes right back up again. So it's kind of a zigzaggy kind of thing. So we have to kind of figure out what's going on in terms of increasing and decreasing. Kind of think of it as a roller coaster ride. So, and you read from left to right. So you would read this as coming from over here, like if you could see like the video running, where would you see the roller coaster car? Well, it would come up from down here and go, come up here and then hit some high plateau and go, ah, and then go right back up again. Okay, so that's what we're looking at. So we have a part that we increase all the way up till we get to a spot, then we come back down and we hit the bottom, and then we go back up. Now the important part about knowing about intervals is there's no equal to's, because like for instance, oh, my calculator just went off. If you are, that stinks. Hold on a second, let me get that back up. This calculator is going to annoy me. But anyway, okay, so I'm going up here, and then I'm coming back down, and then going back up. So if you look at your choices, this says throughout all, this one means all real numbers, and that's not true. Actually, let me make a picture of this before it disappears again. It's still there. It's just hidden on the... Okay, so basically it kind of goes like this, comes up, comes back down, comes back up, well, something like that. Actually, it's a lot nicer than that, and I'm kind of annoyed that my... Still trying to do stuff with my mouse because I keep forgetting that I have a pen. Alright, so basically it's... I'm really having problems with menus and windows and such. But it's basically coming up, going back down, then coming back up like that. Kind of. Alright, so I kind of have to look at these graphs really quickly because my computer only stays on so long. But I can see... Oh! This is so annoying. I got an idea that might work. Hold on one second. Okay, so basically what I did, this is kind of ugly, but I made a screenshot of it so it'll stay on. So basically what I want to do, let me erase this while I have the chance and I'll talk. Maybe it won't let me erase. What the heck is going on? What the heck is this thing doing to me? Man, this is a rough one. Alright, anyway, so I'm trying to... I don't know why it won't let me have... This is not working still. I'm really struggling with one problem. I'm having a tough time, technologically. Alright, I'm back. Okay, so I'm looking for where it increases. Now the idea here is that X is coming like way down here and coming on up here. Y, I mean. It's going up here, so it's increasing. Well, where's that going to start? That's going to start when X is... When X is going from all the way over here. And it's going to increase and keep increasing until I get to like right... I can't tell because it's off my screen, but it's like -1 or -2 or something like that, and then it's going to start coming down again, and then it's going to start increasing again when you get to the number 2, like right here. Okay, so that's what I'm interested in. So I would 2.5 is not right, but I would pick in like right about there. So this I would pick this one. That's increasing, and then again it'll increase from here on. X starts going up. Okay, so as X starts going up, X is going that way. So that's going to be from 2 to infinity. So those are the two places where the graph is going to increase. And I'm glad to be done with this problem because it's a big, huge headache. Okay, that last problem was a huge headache. Alright, to find horizontal and vertical asymptotes, the first thing you need to know is what letter starts horizontal and what letter starts every vertical. If you don't know that, you're already in trouble. Okay, verticals always start with x equals, and horizontals always start with y equals. Okay, so basically now what we're going to do is we're going to find all our problem areas. Well, the vertical asymptote comes from the denominator. So x minus 3, we set that equal to 0, and x is equal to 3. Okay, so that goes here. The y equals, we do, like I said earlier in the videos, you take the degree of the top, which is a 1, and the degree of the bottom, which is a 1. Since they're tied, you write y equals 4 over 1, which is equal to 4. Okay, so this is equal to 4. So that would be this one. And this is a click and drag. You would click and drag these into the boxes. But if you get those numbers wrong, you're already in trouble. So just be careful. Alright, this next problem, you're doing permutations and combinations. All you have to know how to do on this one is whether or not you order matters. Okay, you have a store owner who employs a total of 3 cashiers and 7 clerks. The owner plans to select a committee of 1 cashier and 2 clerks. What's the number of committees that this owner could choose? Again, it doesn't say he's picking the cashiers first, the clerks first, or what order they're putting in, so you're going to use combinations. So the first thing you're going to do is have him pick his cashiers. So he's going to do 3 cashiers. That's the pool he gets to work with, and he's going to pick them one at a time. Times, now he's going to do his clerks, 7C2, and you put both of those in the calculator, and that is under the math. Okay, and then under the math key, you click math key. At the top, you look for PRB, and then you'll choose the C. Now, the important thing is you have to put these numbers in before you go and hunt this down, because it basically looks like this: 3NCR1. Okay, so you're picking the 3, you're going and picking this from the menu, and then you're typing in 1. So the 3 is going to be entered in for the N, and the 1 is going to be entered in for the R, and it's going to give you an answer. Okay, and if I remember right, let's see, this was, oh gosh, I don't even remember what the answer to this one was. Let's see, this would be 6 times, let's see, 6 times 21, or no, 3 times 21. 3 times 21, so that's 63. We should get 63 out of that. Alright, let's go on to the next one. Okay, throughout which interval is blah 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 increasing? So it's the same question as before. So basically you just put this in the calculator and take a look at it and pick your choices. I'm going to try to bring this calculator up again, so hold on. Okay, so I put the equation into the calculator. I hit graph like I did before. Imagine that, cubic looking the same thing, and we're looking for when it increases. Okay, so it looks like it's going to increase from it says throughout which interval is it increasing. Okay, so, and we got these different intervals to look at. Now these are the x values. So let's do the first one. From -2 to 0, it's increasing. Now that's not true. As x goes from -2 to 0, it's gone up and it's gone down. So it's not. That's not right. Okay, we're gonna have technology fun tonight. I can tell. I don't have patience either. All right, next one: -infinity to -1. So that means from all the way over here, all the way to -1, it increases. Now that's right. Okay, so as x goes from here all the way to here, that means as you're, picture this, as you go and you click points on the graph, as you're clicking points, the x values are highlighted on the graph, which again is erased. But that's the one you want. Okay, and then the rest of these, this is junk. And then this one I think probably goes up and down, but that's the one you want. It increases the whole time. The graph goes up the whole time. As you look from -infinity all the way to -1, the graph is going up. It's increasing. Okay, and this one is standard deviation. So with this particular problem, you've got a standard deviation of or mean of 81. They do standard deviations for you. How nice of them to do that for you. What you want to do is figure out approximately what percent this is. So what you want to do with a calculator. In fact, I can even bring up the cheapy cheesy thing. Let's see. Let me bring it up just to show you can even do it on this kind of calculator. You type in 23,750 divided by, where's my divided by? Divided by 50,000. Okay, 47, about 47%. 47.5% is what you want. Okay, so basically what I want to know is how much of this can you fill in. Now, this is you knowing the rules 68, excuse me, 95, and 99.7. You got to know all three of those numbers. Okay, so what you're going to do is 68 counts for from here to here. Okay, so that means each one of these pieces is 34. Now, how do I get these two pieces? Well, I'm going to take 95, which is the next number, and subtract out 68. That's going to give me 17 point, no, not 17. What am I doing? 27? Yeah, 27. That makes this 13.5 and this 13.5 because I'm splitting the two pieces in half. And then the next one is I have, now if you think about it, I can keep going, but look what I'm supposed to do. I'm just supposed to find 47.5. So you could have, let me pick some different colors here. You could have, why is this not letting me pick colors now? Oh boy. Okay, you could have picked this one and this one. You could have shaded. It's going to be one of those click the area types things. So when you click it, it'll highlight. You could pick these two, or you could have picked these two. Okay, either one of those. As long as it totals 47.5, you're good to go. So you could pick those two or those two. Either one of those would have been right. So there's no one right answer. There's two right answers.